All right. So I'm extremely sorry for getting disconnected. All right. Um, is everybody able to see my slide now? All right. Extremely sorry for suddenly my Mac is rebooted and I don't understand why. All right. All right. Coming back to the question. So this diagram clearly states as in what's going on inside Yarn. So the application which is you, the client, which is say Hadoop will provide its own command line to submit a job. Using that, you submit a Yarn application essentially. The, and it will this Yarn application contains the all logic about MapReduce. Similarly, if you are using Spark, Spark's client, Spark provides its own client, and using that you submit your work to the resource manager. Resource manager gets the work done and responds back. All right, and that's what it is. Now, in the resource manager, you when you submit a Spark application, it talks to the node managers and find out which node manager is free. And once it has found it that okay, this particular node manager is free, it asks it to start a container, and inside the container the new applications process will start. And once this application process has started, it will talk to the resource manager and will again start asking to get other works done. So you can think of this as the job tracker, this as the task tracker. Okay, it could start many more processes because this is your application master. Okay, so 4b responds to your application master. Okay, here the work is being executed by application master on each individual nodes. All right, Randir, make sense to you? Are your previous question cleared, or do I need to answer it? There were few questions. All right, let me also try to explain. So initially, when a resource request goes from your application to the resource manager, it includes, hey, how many containers? Uh, I mean, I want these many containers. Want this much memory, and can you allocate me these many CPUs? Okay, along with that we have it when application master talks to the yarn talks to the resource manager, it also tells that hey, I want these locality constraint as in here is my file, can you give me the CPUs and the containers near to this file? That is locality constraint, either upfront or as you go. There are two kinds of requests which the application master or the client can make to the resource manager. One is either upfront, meaning, all right, I need 5 machines, that's it. Or it could also say that hey, I am a flexible, I am application master, I am a job tracker, I might need many more servers. Okay, so be flexible to you. So there are all kinds of resource requests that go to the resource manager before the work starts. I think I need to start the recording. Yeah, recording is started. So keep reminding me in case I don't start the recording, because I sometimes forget, specifically when the machine gets rebooted, then sometimes I do forget. All right. Now, okay, so there is a question. Let me answer one question. I hope our work is saved. All right. Next question is, does each task have one application master only? Does each task has one? Yep. When we say task, it's basically we are talking about each application. So if 10 people are executing MapReduce job, me, you, or somebody else, still there will be a single application master. If I'm using MapReduce and you are using Spark, then there will be two application master, one for MapReduce and one for Spark. Make sense, Rini? Yeah. Did I make sense? So application master is per application. As I was telling you that on Yarn there could be many kind of applications that could run. So for each application there is only one for all instances of the same application. There will be only one application master. Okay. Running an application master is more like installing a program which will execute many number of programs. Are you able to hear me, Srini? All right. Did I answer your question? All right. So I think there was some question pending from your side. Let me. Okay. In federation, do we need separate machine for client? No. It's basically in the client itself. Client is a program which reads its configuration. So it's part of the configuration. It's in the file, not in the service. Is it clear now? Okay. Oh, okay. It was a paste error. Okay. All right. It was a copy paste error. All right. Never mind. Okay, so now there could be many different kind of application. One is, the kind of interactive application. You submitted something, it will do something and respond. Then there are different genre of applications. For example, a database. A database might keep running 24 by 7 for the whole next 10 years, right? So those kind of applications are also valid application masters. Okay? Those kind of applications are also valid application master that could run on top of Yarn. Therefore, application lifespan, as in when to finish, when to not finish, kind of thing is it varies dramatically. It varies too much. Some application, like for example, MapReduce job, you start it, it'll finish in maybe 10 minutes, and once it's done, it'll respond back. But in case you are running HBase on top of Yarn, it will keep running for lifelong. All right. So for that, Yarn categorizes the lifespan into three categories. One is one application. per user job, meaning the user requested something, application got executed, application ended, and then the end of the story. Okay, the process ended. Next is one application per workflow or user session. So for example, if you think about you in a Spark, you start you start a command line and you keep on talking to Spark backend continuously until you exit. So it's one application per workflow or user session. As soon as user exits the console, only then the application ends on the backend. Otherwise, it keeps running and waiting for your inputs. And then there are long running applications such as Impala and Apache Slider, which are always on. So you generally categorize your application in any of these three buckets and tell resource manager, hey, this is long running process, so don't kill it, please. This is the one application per job, as in whenever I'm executing job, run the application master, close the chapter as soon as the as soon as the job finishes, and then inform it back. Okay, or maybe it is a per workflow, as in keep doing the job until there is an exit command comes from the client. So there are these three categories of resource request that goes to the yarn. All right, so that second point here, when we talk about, when we ask yarn, or when we ask resource manager that, hey, this is what we want. Okay, so either we tell upfront that, hey, this is just one application per job, or the application lifespan will decide as to what kind of resource request we want. Correct. So Bala's suggestion is that we keep the QA to the end. Don't worry, we will move some of the questions to the end. If the questions are not pressing, if they don't need to be answered, I generally move them to the end of session. Okay, just that I got, I felt that there was something wrong in the last question. All right, don't worry. Yeah. So we will try to keep the questions to the end. All right. Now, if you have to build a yarn application, okay, if generally what happens is there are already so many yarn application. An example of yarn is MapReduce, Spark, and all kinds of frameworks are there. When if you really want to build your own yarn application, you first try to use existing frameworks such as MapReduce, Spark, etc. Second, try to utilize existing tools to build job. Apache Slider is a very good example. Okay, so Apache Slider can run existing application such as HBase inside it happily. You don't have to create things from scratch. Second is you could use Apache Twill, which basically make any Java thread which is runnable into a yarn application. Okay, or if you don't, if you are still, if you are not able to use MapReduce, Spark, or you are not able to use Slider or Twill, and you want to start building, be aware that building from scratch is complex. Okay, you should start with yarn projects bundled example. Yarn comes up in the examples folder. You will find this distributed cell application, which is really good, and you can extend that one to meet your requirement, or you can modify it, alter it to meet your requirements. So if you are really focused on yarn, um, building an application, then you can go this way. This is the right approach. All right. So yeah, we have gone through the cluster, we have gone through Ambari, we have gone through Hue, we have connected to the cluster. We have this is although this is no longer valid because we have the web interface now. The make directory copy on HDFS. Yeah, it's all good. Now, okay. All right, let's try to. So, is everybody able to create directory and copy on HDFS? Please raise your hand if you're done. I can see the raise of hands. Okay. So Srini is able to make directory and copy on HDFS. Ganpati is able to do. Good, good. All right. So who else? Okay. Sridhar is also able to do. Brilliant. All right. All right. For others, do you need any input from me right now on how to do the make directory in HDFS? So we have gone through Ambari. We have been able to SSH. We can simply open that. And then we can either do the make directory and copy on HDFS using the command called Hadoop, Hadoop FS. Okay. And and you also can do with Hadoop FS, you can say either copy from local and copy to local, or you could use mkdir command using the shell. All right. Now let's move on. Let's move on. All right. So here we are. So we have already talked about it, and this has changed. So these all things will have to be changed. All right, these all things have to be changed. So in place of this, we have in place of Hadoop 1 no big data, we have h1 dot no big data and h1 h2 h3 dot sorry not no big data cloudxlab.com. Okay, because lots of people have asked for the cloud labs, so we have separated cloud labs from no big data, and we lots of people are using it. Okay, even the government agencies are using it. Okay, so yeah, although the machines are different for some of them, we are consolidating now. All right, you could simply log in to either using putty to h1.cloudxlab.com. All right, or you could, if you are on Mac, you could simply do h1, and here is your login, whatever login which we have provided on the as per LMS. Okay. All right. Good. So you could say here again in the same way, or you could simply open the web interface on H2. Okay, you could even say H2. Alright, we have already talked about all of these, so I'll try like to move on right now. We also had discussed how to find out the details about each file. Have a look at these commands. Using this command, you can copy the file from local file system to HDFS, as well as here it says that find out all the blocks and location of a file. You can change the replication factor to 4, okay, like this, as we demonstrated in the last session, and then you can again check the status. Okay, please create your own folder and put your work there. All right, all right, let's try to execute a command. All right, all right, looks like, yeah. So I have to, yeah, just give me a second. All right, I would like to copy this file. Hadoop C Hadoop fs minus copy to local data slash word count. Alright, I will. Alright, where is my CloudX lab SSH? And I'll say your login account. What was the login? Alright, we had a no big data my courses. Okay, so this is the login. I'm trying to use terminal. You can use the maybe this one here. I'm just getting some data from somewhere. Okay, just so that I can run some examples. And yeah, so I can say Hadoop fs, not Hadoop fs, scp student at, this is the old servers which we had. nobigdata.com, and I'm trying to say, what was that folder? That folder was here, asciri slash word count to this. Okay, now I'll say Hadoop move from local and word count input this to asciri. Hadoop fs minus ls. Okay, so you can see that it has created, it must have uploaded this particular file big.txt to my folder, you see, asgiri slash big.txt. Okay, now I can run my program on top of this. Okay, now let's try to run. So this is on I mean our here. Let's try to run. Let's try to see if it user asciri. Yeah, not here in the terminal. Where is our terminal? Here is our terminal. We are saying Hadoop jar. You can see the way we were using Hadoop command for file system manipulation, we are using Hadoop jar command, and with some library examples. This is the pre-created examples that come with Hadoop, and that location might differ from one machine to another. We'll have to correct that maybe. And we are saying that use the data which is located in this folder. Let me just remove this. It's so my folder is in where? My folder is here. So here is my, not here. Where is that user folder? Everybody's data. Okay, so here is the user folder, and under users there is data from various people, and then here is my data. Okay, all I'm trying to do is I'm trying to churn this file for the word count. Okay, so not here, I mean here. So I say user slash asgiri, not asgiri, there is some other username. The other username is this one. And I'll say put the data in the output. So it's a standard example that comes. So this is the jar program. The jar program runs like this. It says it's not a valid jar, which means we'll have to find this. And the way to find is name star Hadoop star dot jar and to dev null. So there are so many libraries, and probably we will go with this one. Not this one, we will go with this one. Okay, do you see somewhere examples written? Hadoop MapReduce examples. This is the location our all right. Ouch. Looks like some service is down. Don't use that one, Ganpati. Use the new ones. Actually, the hosts have changed. Okay, hosts have changed. Instead of using the no big data, these are the hosts. Okay, so you'll have to say instead of student, you will have to use this username at. Instead of saying Hadoop one dot no big data, you will say h1 dot cloudxlab.com. Okay, we will update the document because this is happening recently. Wow, what has gone wrong? Something seriously wrong. Suddenly, suddenly there's something seriously wrong, and yeah, ouch. Looks like there is some emergency. Looks like there's some emergency. All right, maybe we'll look into it again after this thing. So let my people look at it. Some service has gone down badly. Okay, so let's have a look at it. What's going on with this? So the heartbeat of some of the nodes is down, which means this is a mayday situation. Never mind, we will have a look at it at a different time. Yeah, the services are down because it says clearly here. It says clearly that one is that there's a question mark in front of all the services. Here, the secondary name node says heartbeat lost, and data nodes are saying 2 out of 3 are live. Data nodes status 2 out alive and 1 is dead. Okay, so that is the situation. And also here, you when you take the cursor here, it says clearly this particular machine is down. Okay, the H2 basically, the H2 is down. I'm trying to restart Ambari agent. So the agent is up already. We will need to understand what's going on. Okay, you can see that when you take the cursor, it shows you clearly what's going on. So maybe what I can do is sudo reboot. Service Ambari agent status. And here also I'm going to say reboot. By mistake said reboot on H1. Anyway, everything is rebooted now. Alright, now there are few questions. Let me answer those questions. Alright, Randir's question is, when H2 is down, should it still return run application and give us count? Yeah, because so here the node manager, one of the I think resource manager was down. Okay, that's why it was giving us error that you cannot run the application. Okay, it was not able to run the application. All right, Ganpati, you got the answer for your question related to the login. Now there was one question which has been pending for quite some time. The question is how the user job will be processed when node is down and where application manager is running in the middle of processing. Yeah. So what happens is, in case application manager is running in the middle of application and the user job and the node is down. Okay. So let's say one of the container is down and application manager is getting work done through three containers parallelly. And one container got down. It will immediately give the same work to some other node and get that done from there and ignore all the work which was done by the task which was done by the task which is dead. Okay, so this is how it works. All right, Srini, does that answer your question, Srini? All right, all right, looks like things are up again, and let's see if I'm able to see anything. What if application manager is down during processing? If application manager is down during processing, you get an error that a job has failed. All right. Okay. So I will restart the systems and we will try to execute the MapReduce again at later point of time. Right now I cannot log in because I'll have to see the password and all, and that too. Okay. Okay. So, all right. What if application manager is down during processing? The application fails. You get an error. All right. We will run this job at later point of time, maybe tomorrow. All right. Here are few things to think about. So I have actually Ganpati. Actually, I have turned both of them down just now. So just after this class, I'll switch them on back, and then we'll look into it. All right. Anyway, so that MapReduce is not stopping us from moving ahead. So here is a question for all of you. If you have a big plain text file of all of the Lord of the Ring books, how would you find the frequencies of distinct words? How many times each word has occurred? If you want to count that, how would you do it? Anyone? Are you with me? Okay. Sridhar says that we will use unique minus C. Good. But do you think before that you need to do some operation? That's a very good answer, Sridhar. I just am looking for because it's a plain text file, which means each line contains multiple number of words, and the data is not sorted. So you will do some work. Bala says that use simple while loop. Okay. Ganpati says first get list of all words. Okay. Sort those words and aggregate. Good. Okay. In a while loop. All right. Keep going. Keep going. Yeah. Okay. So we'll talk about MapReduce at later point of time. Okay. Right now, let's try to understand the exact problem. What kind of problems do we face? So it's a very simple assignment. I think if your manager or your boss could have asked you, hey, here is the data and all you need to tell me the frequencies of various words. So we have very good approaches. All right. One is using Unix command. Good. Thank you, Sridhar. Okay. Using a programming language, which is from Bala. Okay. And Ganpati's way is using probably an SQL kind of thing. Okay. So, all right, all right. Yes. So here, so Pawan's way is they split the line with the white space character and do the word count. Yes, I want to see how would you do the word count. So this is Sushant. Probably Sushant, you may want to replace stack with hash table. Yeah, because I think that's what you want to see. Good. This is from Randhir. Brilliant answers. Brilliant answers. All right. Great. Great. So we have got three different answers essentially. I have noted it down already in the same manner. So the first way of doing things is probably Bala's way of doing, and Bubala and Sushant. So if you have a plain text file, what you do is create a frequency hash table or a dictionary. Okay. For each word in the file, increase its frequency in the hash table. Initially, if the word is not found in the hash table, mark it at 0, or for the first time, if you encounter a word which is not there in the dictionary, its frequency is 1 and save it to the dictionary. Okay, and once you finish reading all of the data from the file, you print what you have accumulated in the hash table. All right. Is this approach clear to everyone? Okay, so we have one more approach from Ganpati. It is write a Java program to identify all words, write in a file, and with each word as individual record, then sort the file. All the same words will be arranged together. Then aggregate the words. Brilliant, brilliant. Okay, so these are very great answers. Let's go through these answers one at a time. All right, we will go through all possible approaches for this problem and then see what are the challenges we will face in each. Okay, so this approach is clear to everyone. It's basically a programming way of doing things. We create a dictionary. A dictionary is a big data structure containing collection of name and value. The way in a dictionary there is a word and the definition, right? And each word is kind of a unique, or you can say the dictionary is sorted by the word. Now, the quality of the dictionary is you can quickly look up a word and find its meaning. Here, in our example, the meaning means number of times the word has occurred. Okay, that's the thing which we are retaining in our dictionary. So we create an empty dictionary, read a word, put it in the dictionary with count as one, then read another word and then find if it is existing in the dictionary or not. If it exists in the dictionary already, we increase the count, and then if it doesn't, we insert it with a one as count. Okay, is the approach clear to everyone? Yeah. Some of you have already given the same approach to me. No? Only Srini is clear about this approach. Now, question to all of you is, if you have understood the approach, what exactly is wrong with this? What is wrong with this approach? Do you think This will fail in any circumstance. What happens when the file starts growing big and big? What if the data grows to 10 gigabyte? Will this approach hold good? What will be the bottleneck? Sridhar says it's time consuming. Pawan says the hash table might grow big, billion, billion. Bala says hash table does scan which will slow down. No, hash table does not do the scans. Hash table are really fast when it comes to lookup. Srini says it is the memory which is going to be the time consuming. It is the memory which will overflow. Brilliant. Brilliant. Any other answers? What kind of problems do you foresee with this approach? Anybody else? Okay. You cannot process data which is beyond RAM size. Wow. We are 5 minutes late. So, yeah. Okay, so this is the first problem which you will face. And all those people who are coming from our background, okay, actually suffered this kind of problems where when they started working on R and then suddenly the memory overflows and they can't do anything. Bala says the loop won't read newly added data. Yeah. All right. So, okay, let's continue this discussion tomorrow and we will go into deep as in how to think in terms of MapReduces. I want to emphasize because it's not only the MapReduce paradigm which is important at this point of time. The same paradigm is also utilized in many applications, such as even Spark uses a similar paradigm. Okay, so it's very important for any distributed computing to understand how does the whole MapReduce idea comes around. Okay, that's why I want to spend more time on this. All right, all right. So that's pretty much for today. We will see you tomorrow and have a great day. All right. Thank you, Randhir. All right. Thank you, everyone. Have a great day ahead. We will see you tomorrow and we'll continue the discussion from thinking in MapReduce. Bye bye.